All right, guys, we're going to be going over Thursday's packet right now. So 2 pages with understanding rate concepts. Let's get started. So number 1, it takes Maya 30 minutes to solve 5 logic puzzles, and it takes Amy 28 minutes to solve 4 logic puzzles. Use models to show the rate at which each student solves puzzles in minutes per puzzle. So with these models, we've learned lots of strategies this year. The easiest model to do is a ratio table. So in class, we saw horizontal ratio tables. So I'm going to make this one for Maya. And then I'm going to fill hers in. So we're comparing minutes to puzzles. And I know that it takes her 30 minutes to solve 5 logic puzzles. Okay. So from here, I can find a unit rate, which would be finding how many minutes it takes her to solve 1 puzzle. So I know that to get from 5 puzzles to 1 puzzle, I divided by 5. So that means I'd also have to divide the minutes by 5, and 30 divided by 5 would give me 6. So I know that Maya takes 6 minutes to complete 1 puzzle. That would be 12 minutes for 2 puzzles, 18 minutes for 3 puzzles, and 24 minutes for 4 puzzles. Sorry, it's not perfect. And then I would go ahead and do the same thing for Amy. So if you're stuck on this question, hit pause right now on this video and then see if you can do the same exact thing with a ratio table for Amy. Okay, so my ratio table for Amy looks like this: 7 minutes per puzzle, where Maya's was 6 minutes per puzzle. So if Maya and Amy had the same number of puzzles to solve, who would finish first? In this case, Maya would finish first because she completes puzzles 1 minute faster than Amy. And I actually need to go back and edit this. Maya would finish first because she completes 1 puzzle 1 minute faster than Amy. So you have to be very specific and use that unit rate, because when we're comparing ratios, we want to find that common number. Okay, so now I'm going to ask you to hit pause again if you were stuck on this, and I want you to try number 2. It asks you to use a table of equivalent ratios to show the garden hoses water flow in gallons per minute and minutes per gallon. So you should still have 2. So hit pause, see how you do, and then check your answer with mine. All right, so here's my ratio tables. Really the only difference between these 2 tables is the order of the numbers, because remember yesterday we talked about how the order of the words matter when you write a ratio. So when you're talking about rates, gallons per minute, so gallons per minute here matches this table, gallons per minute, and then minutes per gallon, minutes per gallon would then represent this table here. So the numbers are the same and the relationship is the same, but the order of the words have to match the order of the numbers. So then your second part of this question, how many gallons of water does the hose supply in 10 minutes? So I wanted to show this live. So in this case, if we wanted to go all the way to 10 minutes, I could continue expanding this table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we know that equivalent ratio tables always have patterns. So to get all the way to 10 minutes, you can scale up from 1 minute to 10 minutes, or you could scale up from 2 minutes to 10 minutes. I multiplied by 10, and 1 times 10 gave me 10 gallons. So 10 times the amount of minutes would be 10 times the number of gallons, which would be 120 gallons of water. So the hose supplies 120 gallons of water in 10 minutes. So there's your page 5. Let's take a look at 6 now. So still very similar. Again, hit pause if you haven't done this question and see how you do. All right, so how'd those number lines go? I have mine made. Notice how I labeled miles and hours. I put the original ratio from the problem towards the end because I knew that I was trying to find a rate in miles per hour. So a rate means I have to find per 1 unit. So I knew I had to go backwards on this ratio table, and I found that Max travels 54 miles per hour. We will be discussing this question